All right, here's our next 11.5 example, and I got this one straight from the homework. It's talking about a game that consists of rolling a single die, and it pays off as follows: $8 for a 6, $2 for a 5, $1 for a 4, and no payoff otherwise. Find the expected winnings of the game. Okay, the expected winnings and expected value are always the same. We're going to take the sum of the x times the p of x. So it's up to us to list out the outcome. So we're going to roll a die, and as we roll that die, it's telling us that if a 6 comes up, then what you're going to win is $8, right? So the outcome could be a 6. The outcome could be a 5. If it's a 5, then you win $2. Or the outcome could be a 4. And if it's a 4, you win $1. But if it's anything else, if it's a 1, 2, or 3, you're going to win nothing. And it's these winnings that we want to use as our x's. Now I know I called these guys x's because they were our outcomes, but they want the expected winnings, not the expected value on the dice. What they want out of this is the winnings that are there. And so that's an $8 winning, a $2 winning, and a $1 winning, or a 0. Now let's go get the probabilities of each. The probability that a 6 is going to come up is 1 out of 6 opportunities. Probability of 5 is 1 out of 6. 4, 1 out of 6. 1, 2, or 3, just for emphasis, 3 out of 6. I'll leave it unreduced. There's 3 opportunities out of 6 to get nothing out of that. So how are we going to find the expected winnings? Easy. We're just going to follow the formula. The x times the p of x. And we're going to get 8, 6. And 2 times a 6, 2, 6. And 1 times a 6, 1, 6. And 0 times anything, 0. And so what do we get out of this? The sum of the x times the p of x is 11, 6. Now they may want the answer as a decimal. I don't remember what they asked for in terms of that, in terms of money, but it is money. We wouldn't say I have 11/6 of a dollar. And so we have 11 divided by 6. Delete something really quick. And that is 1.83. $1.83 is the expected winnings. And so that's what you would expect to win. Then you have to decide, well, because you're going to lose a lot of the time. Over half the time you're going to lose, or about half the time you're going to lose. And some of those times you're not getting a big dollar amount. And so you're going to get $1.83 if you play this in the long term. So if your cost to play is under that, then you'll make money. But if your cost to play is over that, then you're going to lose money in the long term. So for example, if it costs us $2 to play, well, don't play this game because you're not going to recoup your money. But if it's only $1, play it, because in the end you're going to make money. And you can make some really good decisions off of expected value. But that answers that question at $1.83. Okay, the next question's a little bit more involved. So let me bring this down. So suppose it costs you $22 to roll a pair of dice. You get $3 times the sum of the numbers that appear on the dice. What is your expected payoff of the game? Is the game a fair game? Now the $22 that they're mentioning right up front actually is the last thing that you consider. So I'm going to just take some time to move this down because this is going to take us a little bit of work. So remember the sums that could come out as you roll a pair of dice. So the actual outcomes on the pair of dice are, well, from a sum perspective, you could get a 1, or you could get, oh no, you couldn't get a 1, a 2, a 3, a 4, a 5, 6, 7, 8, 9, 10, 11, and 12. There's 11 different sums you could get. And what we need to do is find the probability of each. Okay, and let's figure out the probability and then go back to the question. Okay, So what's the probability of rolling a 2? Well, 2 can only be rolled with the 1 and a 1, so that's 1 out of 36 options. Remember, the options are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1... Let me get rid of that dash there. 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. And that goes all the way down to 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. And so you have this big 6 by 6 grid. That's where 36 comes from. Well, there's 2 options out of 36 to get a 3. Here they are. There's 3 options out of 36 to get a 4. What are they? 1, 3, 2, 2, and 3, 1. There's 4 options out of 36 to get a 5, if you count them. 5 options out of 36 to get a 6. What are those 5 options? Just to count that one: 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. And so 1, 2, 3, 4, 5. And there's 6 options out of 36 to get a 7. That's the highest one because the 8 goes back down, the 9 goes back down, the 10, there's only 3. What are the 10 ones? Well, 3, 3, 7 wouldn't work, right? So it's got to be 4, 6, 5, 5, 6, 4, because they're 6-sided die. And then 1 out of 36. Oops, sorry, 2 out of 36 and 1 out of 36. So those are the probabilities. Now, what do we want to find? We want to find the expected payoff. Well, I don't have any money yet. So let's remember how we're going to get paid off. You get 3 times the sum of the numbers. So the money that you get, right, that's what we're going to find the expected value of the money. The money that we get, you'll get 3 times the sum of the numbers that appear on the die. So there's a 6 here, a 9 here. You would get $12 for rolling a 4. 15, 18, 21, 24, sorry, 27. I was looking at something different up at top. 30, 33, and $36. That's what you get. So what are we going to do? Well, we're going to get our x times p of x. And I'm writing it in a way where you can track it. So this is 6 out of 36. This is 18 out of 36. This is 36 out of 36. You okay with where I'm coming up with that? 12 times 3 is 36 over 36. 15 times 4 is 60 out of 36. 18 times 5, no clue. 90 out of 36. 21 times 6, use your calculator to be sure, 126 out of 36. And you could string this together, but I wanted it pieced apart in case somebody was wanting to track it. And what I meant by do it all together, just drop it in on your calculator and just keep hitting pluses in between. 108 out of 36, 90 out of 36, 66 out of 36, and 36 out of 36 for that last one. Okay, now we know what we need to do. Let me give myself some room over here. So some of the problems are involved like this. Many are not, but there were some layers to this question. It was very simple in its direction, but you needed to come up with the probabilities by seeing the sample space, and then you needed to understand the question. So we're still not done. The expected value of what we need is going to be the sum of these x times p of x's that we just found. So I'm going to try to do it in a logical way. I'm just going to add the numerators. 6 plus 18 plus 36 plus 60 plus 90 plus 126 plus 120 plus 108 plus 90 plus 66 plus 36 equals. I got a total of 756 out of 36, which is 21. And that's what I remember the answer being. So again, how did I get the 756? I added the numerators, and then the 36 was the common denominator that was there. So I chose not to put them in the decimal form so you could better track what was happening. So if I take a step back, what we first looked at is all the different totals that could be there. The probabilities of each one of those totals by considering how many ways there were to roll a total of 7. There were 6 ways out of 36. Then we put the money. The money was 3 times the total. So that's where these numbers came from, is 3 times 2, 3 times 3, 3 times 4, all the way up to 12. Then we did the money times the probability, because that was the expected winnings. Now remember, they wanted to know the expected payoff of the game, $21. Is it a fair game? The answer is going to be no, and the reason is they charged more. Oops, let me get the H in there. They charged more than the expected value to play. Now, no game that a casino or anybody else is going to do is going to be fair to you. They will always make it so that they make a profit. And so what you can find is that they're making $1 profit every time this game's being played. There's lots of winners, there's lots of losers, and in the end, the way that they're paying off, they'll make $1 per every time somebody plays this game. So if they want to make more, they charge more. If they want to break even, or if you try to make it a fair game, then it should only cost you $21 to play. And so that's the style of questions that are in here. So we got these game types of questions that are here. Now there's other questions as well, right? Some more questions that involve games. I'll save these for the third video so that they don't get too